So, welcome to the class of medical physics. In the last lecture, we have discussed about the resistance. We have seen how the resistance have both positive and negative aspects, and we have discussed two positive applications of resistance in our daily life. The one was electric toaster, and the other one was incandescent bulb. And those both were using resistance in a positive way to be used um, for daily routine purposes. Okay, continuing with that, we have last these terminologies in previous lecture: the voltage, current, and resistance. Here we are comparing these all three quantities with the water supply, water hose. Like as you experience the pressure in our running water through a garden pipe, um, that is comparable with the voltage in electrical systems. Similarly, the size of hose will get affects the flow of current. So likewise, the size of diameter of your conducting material wire, for instance, will get affect the flow of current. And how do you compare the resistance if you have sand particles and if you have impurities or any fine particles within your pipe present, and obviously you know that your water will not flow with the same pressure at as the water will flow through an empty and clear pipe. So when if there is a sand, there is a particle, there are small pebbles. If you drop in the water pipe, the water will not flow to the maximum of it. So that is comparable with resistance. Voltage unit, I repeat, is volts. Current is measured in amperes. Resistance is measured in ohms. Next is Ohm's law. The purpose of sharing the definition of voltage, current, and resistance is because they all three were used in Ohm's law. Why? Because resistance cannot be measured in an operating circuit directly. Resistance is a quantity, a measurable quantity which is not physical. So this has caused troubleshooting for technician to often determine resistance by taking voltage and current measurements and applying the Ohm's law, because resistance itself uh, could not be measurable. So we do measure resistance by using the voltage of the circuit and the current flowing through that by using the Ohm's law. Ohm suggested this formula of V is equals to IR. E is equals to IR, V is equals to IR are both are one and the same thing. E only denotes your EMF, whereas I is your current and R is the resistance. So V could be any voltage drop or any EMF. I is again resistance and I is again current and then resistance, current time resistance. How much resistance is experienced by the current is due to the result of applied voltage. Voltage is equals to current amperes times ohms, whereas R is resistance and so on. Okay, Ohm's law and current voltage relationship. This is more detailed to current law. Oh, sorry, Ohm's law. Statement of Ohm's law is that the current I flowing through a circuit is directly proportional to the voltage and inversely proportional to the resistance. What is mean by this? The current flowing through a circuit is directly proportional to the voltage. How much voltage you are applying to your circuitry will result that much amount of current flow, whereas the current is inversely proportional to the resistance. The more the resistance will be there in your circuit, the less will be the current. The more will be the voltage, the more will be the current. The more will be the resistance, the less will be the current. So there is directly proportional and inversely proportional relationship of current with the voltage and resistance. In other words, if we increase the voltage, the current will increase, but if we increase the resistance, the current will decrease. Here is current voltage graph in which we have two axes. In x-axis, we always use um, independent quantities. We always plot on x-axis, whereas we always plot dependent quantities on y-axis. Here, voltage is independent quantity. The more you apply the voltage, the more you will get the current. So voltage is independent one, whereas the current is dependent on the applied voltage. Okay, so we have two readings of voltage versus current. The first one is 3 volt, and consider any circuit diagram, and in that circuit your EMF is 3 volts, for instance. The current flow through that circuitry will be of 1 ampere. For example, you have calculated that, you have measured that. In the same circuit, if you increase the voltage by double, what you will experience? The current has also been doubled by the value. You have doubled the voltage, the current has also doubled. So, and when you plot on those values, you will always experience, sorry, you will always experience a straight line. This is showing the linear relationship between the current and voltage. That is why they are directly proportional, because your graph is increasing from left to right. Similarly, if you plot the current versus resistance graph, resistance is independent quantity. It will be plot on your y-axis, whereas the current is dependent quantity. So you will experience an inverse graph, which will be inverting from left side to right side. From left to right, it will be of in decreasing quantity, like this. If you plot a graph of a graph between the resistor and the current, it will be a straight line as well, but in decreasing fashion. Okay. So this is the linear relationship between the voltage and current defined by the ohm. Here is a circuit diagram in which we are showing you only two components in basic. The one is the voltage source. Let me change the color. Okay. So you have a supply voltage, which is known as the EMF voltage, and then you have a load connected to that battery, that supply voltage. Of course, a certain voltage drop will be happen as potential difference at this point. What other two things are there in the circuit diagram is the one is ammeter and the other one is voltmeter. Ammeter is a device used to measure the current, whereas voltmeter is a device used to measure the potential difference. Now you can see the circuit is very much simple. Let me draw it in a very simple manner again. Your battery and any load. This is all about your circuitry of this diagram. To calculate the resistance through voltage current relationship, and you want to measure the resistance of the circuit. Clear? What will happen? The circuit is complete, the current will start flowing. I am showing you the conventional direction of the current. Current will start flowing through this positive terminal to the negative terminal. So it means there is a flow, as there is a flow of electron, there is a current flowing through the circuit, and there is a battery, the supply as well. So the voltage will be there, and there is a load in the circuit. So a potential difference is also there within the circuit. A voltage drop is also there. So a voltage drop is also there, which incorporate the potential difference at point A and point B, if I name it. Now, I am asking you to tell me the resistance of this circuit. As we have discussed previously, that we cannot measure resistance directly, so, but we can measure it by using, hold a sec. Okay, but we can measure it. Okay, but we can measure it by using the current and voltage. Now, how do you use the voltmeter or ammeter to measure the current and voltage? In order to measure the current, you need to break the circuit. You need to break the circuit. How you will do that? Um, this is a little complicated to deal with this. Apologies with my drawing. Okay. You will simply break the circuit and you will attach an ammeter between the wires after breaking the circuit. Why we have done that? So why we have break the circuit? I'll let you know in a while. Okay. Why we have done this? Because when electrons start flowing through the wires, either in this direction or that, whatsoever. So this is the passage of flowing of electron. So in order to calculate what is the definition of current? The flow of electrons. So how much electron is flowing throughout the circuit, through the circuit, will be measured when the electrons will flow from this ammeter. The electrons will start flowing through this ammeter, will gives you the calculation of current. So that is why we use ammeter in series with the circuit. Connection of series is like if a person A holding his hand with person B and person B is holding his another hand with person C. So this is a series arrangement. And what will be the parallel arrangement? If any person, any fourth person will comes and hold his both hand with person B is the parallel arrangement. D is connected or is in direct contact in direct contact with only B. So this is your parallel arrangement, whereas series arrangement is that the B is having the contact with both C and with A. If you forget about the D, so B is in contact with C and A as well. So this is this series arrangement, whereas if any component is in contact with a single component, this is the parallel arrangement. Clear? Okay. So this you always need to attach ammeter in series connection with within the circuit to find out the flow of electron, that how much electron is flowing through the circuit. Whereas in order to calculate the voltage drop, the difference, the potential difference, you need to connect the voltmeter always in parallel with the component which you want to measure the voltage drop. So voltage meter will always attach in parallel to any element of which voltage drop you are interested to find out. So in order to calculate the resistance of a whole circuit, you need to find out the current, the complete current flowing within the circuit, and the complete voltage supply of the circuit. So complete voltage supply will be calculated by the potential drop of this supplied voltage, that is battery. The EMF will gives you uh, through voltmeter in parallel, whereas the current of the whole circuit will be calculated by using a ammeter in series with the circuit. So keep that in mind, that ammeter will always be attached in series with the circuit, and voltage drop, the potential difference, will always be measured when you attach it in parallel combination with the circuit. So this will give you the voltage drop of the whole circuit and voltage current of the whole circuit. And by putting them up into the formula of Ohm's law, that is V is equals to IR, you will get the resistance of whole circuit. You only need to separate out that R from the formula, and by sending the current on left hand side in denominator, will gives you the value of resistance of the whole circuit. Clear? But if you want to find out that how much voltage this load is using, the load is consuming, you simply need to attach voltmeter in parallel with that load. Will give you that how much voltage is consuming by this load. So I guess this is pretty much clear now, and quite this is quite simple to understand. And if you increase, for example, your supply voltage, your battery is of 5 volts, for example, you will get a certain value. Let me change the color because there is a little mess. Okay. If you supply a 5 voltage if you attach a 5 voltage battery, you will, let's say, experience a 1 volt of current. If you increase it by certain difference, let's say 10 volt, for example, you will get 2 ampere of current. The double of it, the double of this. Next, you have 15 volt, and for example, you are getting 3 ampere. So when you go and plot all of these values on x-axis and all of these values on y-axis, you will get a linear relationship like this, where you have a fine slope and that value of slope, that is that value of slope will give you the value of resistance. Slope is what? Slope is the measure of the gradient between your y-axis and x-axis. So by this slope, you will always get a constant r. This constant r means you will get, for example, if you plot these values or you calculate or you always um, use this formula of Ohm's law, you will get the same r all the time. 5 upon 1 will give you 5. 5 what? 5 ohms. Next, 10 by 2 will also give you 5 ohms. Then the third case, that is 15 volts. The current you have experienced or measured, let's say 3 ampere. So you will have, you see, you will have the same resistance in all after all of these measurements. So that is why you are having a straight line graph due to the constant r, which is showing you a linear slope. Linear slope means their slope or gradient is same all the time. That is why the relationship between voltage and current is linear, linear increasing graph. So I think this is pretty much clear now. Okay, so Ohm's law is a quite interesting relationship and very much helpful, which is showing you a linear relationship. Okay, this is a little more explanation that current is directly proportional to the voltage. You increase the voltage, you will get more current. Here are few problems, and in all of them you need to find the unknown values. The first one, the current is unknown. In the second one, the resistance is unknown. Whereas in the third one, the voltage is unknown, the EMF of the battery is unknown. So you can easily solve all of them. Next is type of resistances. We have numerous type of resistances. You name it as fixed resistors, variable resistors, thermistors, light dependent resistance, the LDRs, potentiometers, rheostat, varistor, photoresistor, carbon film resistors, metal resistors, and bi-wound resistors. They do have all the same, they all have same purpose for resistance, but they do have different properties. That is why they are being differentiated. Next are few electrical components and their units, which are very much useful to understand the electrical circuits, the electronic circuits. You need to learn all of those symbols. So when you have your hands-on practice on circuit diagrams, you need for hands-on practice, you need to learn all these components. This is cell circuit. This is DC circuit symbol, voltage source, current source, AC voltage source, control voltage source, control current source, battery circuit, AC circuit symbol, fuse circuit, solar cell, transformer symbol, and the earth. Next are few system international units which the whole worlds follow. The one is capacitance. Capacitance is denoted by C. The unit is farad and the symbol or unit is F. Then the charge Q and the unit is coulomb. Current I, ampere A. Electromotive force represented by E, measured in volts represented by V. Frequency denoted by F, small f, measured in hertz represented by Hz. Inductance, Henry, period, second, potential difference, voltage, power, watt, resistance, ohm, temperature, Kelvin, and time in seconds. We will see all these measurable quantities at different times. Okay, next are few formulas, the basic ones by using all these all these electrical quantities. Few are magnetic as well. The first one is voltage. How can you calculate voltage using the Ohm's law, of course? V is equals to IR, which is measured in voltage. Then we have current, which is measured in ampere and isolated from the Ohm's law formula by separating I and from V is equals to IR. Then resistance, similarly, we can calculate resistance. Conductance, what is conductance? Conductance is the capacity of conducting of the conductance is how much electricity is conducting or passing through the circuit is your conductance. Basically, the conductance is nothing but the opposite of or the inverse of the resistance. The more will be the resistance in the circuit, the less will be the conductance. The less will be the resistance in the circuit, the more will be the conductance, vice versa. Like it is measured in Siemens. Next are power. P is equals to VI, voltage times current will give you the power. How much voltage you are applying to the circuit and how much current is there in the circuit due to that applied voltage, their their multiple will give you the power. Then capacitance, inductance, impedance, charge. Charge is measured by C into V. Capacitance time voltage. Next is frequency, inverse of the time period, and time period is the inverse of frequency. The more will be the frequency, the less will be the time period of waveform. The more will be the time period, the less will be the frequencies of the waveform. I am I have left with two of the quantities. The one is inductance and the impedance, because these two are going to be discussed in uh, near future in inductance in the topic of magnetism and impedance when we discuss with the AC circuits. Here are also example of linear relationship of current voltage and the resulting resistance. Uh, okay, so these are all batteries. Each battery is of 1.5 volts. So as soon as you increase the number of batteries or decrease the number of batteries will give you the similar effects. That's what this slide is showing you. Each battery is of 1.5 volt. You have two batteries, you have 3 volt in total. You have four batteries, you have 6 volt. You have six batteries, you have 9 volts. Two batteries, again 3 volts. What is different into them is that the current is you have doubling up the voltage by certain equal amount, and the current is increasing by the same amount, but the resistance is same throughout the linear relationship. Likewise, again, if the current is increasing by a certain other different amount, but the resistance will remain the same accordingly, right? Okay. Next are chemical effects of current, another important aspect. William Nicholson, a British chemist, discovered electrolysis of water, demonstrated that bubbles of oxygen and hydrogen are formed when electrodes are submerged in water and current is passed through that water. What they are saying, he wanted to find out the chemical effects of current. What are the chemical effects that that can be found when the current is flowing? Because current flow of current is a complete mechanism. So he did an experiment through electrolysis of water. What he done is he has done electroplating. He used a jar. Okay, why did he use the jar? I'll let you know later. He took a circuit within which he had a battery and he attached two simple metal plates termed as electrodes through them. Okay, so he had two electrodes attached to that. Okay, what will happen if I connect a conducting wire through those electrodes? My circuit will be complete, but without them, circuit won't be complete. So, but he didn't completed the circuit by using any solid conductor like this. What he did, what he actually did, he used water to find out its chemical effects. He used water and submerged those electrodes into the water bath. Now, as we know, the water is a good conductor of electricity, so your circuit is eventually complete now. The circuit is complete now because the two metals are connected with each other through a conducting material, and water can conduct electricity. So he wants to check the chemical effects of conductivity, the current. So he did that experiment. What happened once the circuit was completed by the presence of water? The current starts flowing from positive terminal, let's say, to the negative terminal or whatever. The current start flowing because it has a complete pathway. Okay, so the conduction pathway was complete, hence it is no more open circuit but closed circuit, so conduction will start. After as soon as the conduction starts, what happened? The two processes occurred at that time. The one was the electrolysis of liquid, that in case water is here, electrolysis, and second process was electroplating. First one was electrolysis and the second one was electroplating. Okay, what is electrolysis? Basically, electrolysis is nothing but the breakdown of H2O molecules into H positive and OH negative. The ionization of water molecules is known as electrolysis. Not only the water molecules, but any liquid component which gets breakdown due to the presence of current or will polarize. So the process is known as electrolysis. It breaks into H positive and OH negative ions. Okay, now this is your process of electrolysis. This is the breakdown of water molecules, or for example, if you say a solution of NaCl, the breakdown of NaCl into Na positive and Cl negative will be termed as your electrolysis process. when NaCl will break into Na positive ion and Cl negative ion will be your electrolysis. So, what is electroplating? As the term is indicating, the plating, the serving purpose, you have positive electrode and the negative electrode. So, the positive charge elements or the positive charge particles, that is H positive in case of water solution or Na positive in case of NaCl solution, the H positive will go and attach to the negative electrode, and in case of NaCl solution, all the Na positive elements will go and stick to the negative electrode. Basically, they get attracted by the negative electrodes because the electrode is negative in nature, whereas, negatively charged due to the such arrangement of the battery. So all positive charges will go and attracted by the negative electrode and adheres to that electrode. This is what electroplating is. Similarly, likewise, OH negative or the negatively charged particle will go and stick to the positive electrode. Um, Consider the OH negative in case of water solution and chloride negative, Cl negative in case of NaCl solution. So the deposition of those charged particles on electrode will can be experienced physically or can be visualized by your naked eye. So this is the deposition of sulfate ions or the copper ion in case of like copper sulfate solution as written over here. The deposition of these ions on electrodes is known as electroplating. So he found the chemical effects of current that it contributes in electrolysis and electroplating mechanism. That was the whole experiment all about. Clear? Okay. Next is he found that the hydrogen bubbles are formed at the electrode connected to the negative terminal, while the oxygen bubbles are formed at the electrode connected to the positive terminal. Uh, okay, when an electric current flows through the conducting solution, chemical reaction take place. That chemical reaction is basically electrolysis they are talking about. Take place in the solution. This is called the chemical effect of current. Some of the chemical effect of current are as follows. Gas bubbles are formed at the electrodes, metals are deposited on the electrodes, and change of color of the solution, of course, because of the electrolysis and electroplating. Next is, do liquid conduct electricity? Of course, liquid conduct electricity, but not all the liquid can conduct electricity. Like not all the solids are conductors. Likewise, not all the liquid are conductors. Some are insulators and some are good conductors and some are very good conductors. So all liquids do not conduct electricity. Nevertheless, some liquids are good conductor of electricity while other are bad conductors of electricity. Water with dissolved salts and minerals is a good conductor of electricity. Means you are adding the impurities in terms of salts and minerals. When you add them up, you will get a better results. So if you experience the electrolysis process in water solution and sodium chloride solution, you will have better conducting property in NaCl solution as compared to the water because you have added impurities into that. So you have more mineral ions, more salt ions. That is why it will conduct more electricity. While distilled water is a bad conductor of electricity. Here are a few examples. Liquid lemon juice, a good conductor; vinegar, poor conductor; honey, poor conductor; mercury, good conductor; and soda is also a good conductor. Next is, what is the difference between electrolysis and electroplating? We have already discussed electrolysis is a process which uses a direct electrical current to break chemical compounds, while electroplating is a process that uses electrical current to reduce dissolved metal cations so that they form a coherent metal coating on the electrode. They go and deposit on the electrodes. That is electroplating. How can you make pure water to conduct electricity? By dissolving salts in pure water, you can enhance their conductivity. Why does a needle compass when dipped in salt water deflect more than when dipped in drinking water? The seawater contains a huge amount of impurities of salts in comparison to drinking water, and the seawater has more conductivity of electricity and it produces a stronger magnetic field in the wire and hence deflects the compass needle more. Next is, why do firemen shut off the main electrical supply for the area before they use the fire hose? Of course, the water is a conductor of electricity. That is why they are supposed to shut off the electrical supply before using that. The water used in the fire water hoses is not pure and is a good conductor of electricity, so the firemen shut off the electric supply before spraying water to save themselves and other people from electroconduction. Is rainwater a distilled water and a bad conductor of electricity? No, rainwater is not that distilled water due to the acidic rain effects. Rainwater is a pure water, but which is an insulator, but it get mixed with the air pollutants like sulfur dioxide and nitrogen oxides and form acidic solution, which is a good conductor of electricity. So the compass needle show more deflection. Next is type of electric currents. We have two types of electric current, the direct current and alternating current. We will have these the difference in these two current later on in details, but I'll just give you a quick review to that till the next lecture. Direct current is the flow of electric charge in only one direction. This is a graph we will discuss later on. And they are saying that DC voltage and current are constant in time once the current is established, whereas alternating current is the flow of electric charge that periodically reverses the direction. Here is the graph of alternating current. A graph of voltage and current versus time for 60 Hertz AC power. The voltage and current are sinusoidal in the form and are in phase. For simple resistance circuit, the frequencies and peak voltages of AC sources differ greatly. Okay, we will discuss these two difference in current, electric currents in details in our upcoming lecture. Till then, thank you.